Good day, sir. My name is Shiva Sharman Anaraki Panirselvam, and my registration number is 01DKP22F2014. So today I'm going to give the introduction for our topic, which is pounding. So pounding is one of the critical structural challenges faced by ships navigating in rough seas. It occurs when the forepart of the vessel, particularly the bow region, lift clear of the water due to wave action and then forcefully slams back onto the sea surface. This impact generates sudden and high intensity loads on the ship's bottom structure. Unlike regular hydrostatic or wave induced pressures, pounding loads are dynamic and concentrated, acting impulsively on a limited area of the hull. These slamming forces are highly unpredictable depending on factors such as ship speed. The higher speeds increase the severity of the impacts. And the next one would be hull form. Fine bows and flat bottom regions are more prone to pounding. And the third one would be sea state and wave direction. Pounding is most severe in head seas with steep waves. So the effects of pounding are not only uncomfortable for crew and passengers but also structurally dangerous. Pounding can result in denting or cracking of bottom shell plating, excessive vibration in the forepart of the ship, loosening of connections in and misalignments of structural members, and also reduced fatigue life of the hull structure. To counter this risk, naval architects designed the forward bottom structure with provisions for additional strength, such as thick bottom plating in the bow region, closer spacing of transverse floors and web frames, stronger longitudinal stiffness, reinforced connections between bottom side shell and inner bottom structures. Thus, pounding is a design consideration of great importance in modern shipbuilding, especially for high-speed vessels and ships operating in harsh ocean conditions. That's all from me. Thank you.
Good day, sir. My name is Abhyash Ananaki Sankaran, and today I'm going to explain about the provision of the strength against pounding using MIRL analysis. Okay, so first of all, is the M is a high quality materials. It means use of strong, durable, and fatigue resistant materials in construction, particularly steel and welds. Purpose of this is to reduce material degradation and fatigue failure from the repeated pounding forces. After that is we have to apply this in marine hulls, offshore decks and bulkheads. Okay, after that I'm going to explain about the I. I is a inspection and maintenance. It means continuous monitoring of pounding zones for cracks, corrosion or structural wear. Okay, the purpose of this inspection is early detection of damage before it propagates or causes failure. After that we also can apply this in a ship hull inspection. Okay, after is R. R is a reinforcement, framing and floors. It means enhancing the strength of the framing element and deck flooring system, especially in zone prone to impact. Purpose is to help to distribute the pounding force and prevent local failure or buckling. Okay, after that is the L. L is the longitudinal strengthening. So it means the strengthening along the ship or platform's length using deep longitudinal griders and stiffest undershell plating. Okay, purpose of this is for resist hull bending or deformation from bow, stir pounding or wave flaming. Okay, as a summary, we this slide seems to be a form of marine engineering or naval architecture context. This strength provision in a ship hull or offshore to resist impact loads such as slamming from waves, structural vibration from engine, pedal impact, or repeated loading due to the sea motion. That's all from me. Thank you.
Good day, sir, and everyone. My name is Sridharendra Singham. My matrix number is 01DKP 22F 2015. So now I am going to explain the summarize and reference link, guys. So for the summary, we got the pounding is slamming impact load that mainly affects the forward bottom shell plating. Additional strength is provided by thicker plating, reinforced floors, and longitudinal framing. After that, proper design, construction, and maintenance ensure structural safety and seaworthiness. Classification societies also requires special strengthening in bounding regions to meet safety standards. Okay, fine. So on my right there is got a diagram that shows slamming or pounding. When a ship moves in waves, the bow sometimes lift out of the water. As it falls back down, it hits the sea surface with force. This impact happens mainly in the pounding region, about a quarter of the ship's length from the bow. Because of these strong forces, ships need to thicker plating and stronger framing in this area to safe and durable. Thank you, sir.